horizontal asymptotes of rational functions. So we recently looked at vertical asymptotes and wholes of rational functions. Now we're going to identify horizontal asymptotes of rational functions, like vertical asymptotes, if they exist. Okay, so we know what a rational function is. It is a quotient of polynomial functions. We know what a polynomial function is. And the key for this lesson with the polynomial function is the largest exponent, the highest power, is the function's degree. We want to remember that. And we know what an asymptote is. It's a line that guides the graph of a function but is not part of it. So what is a horizontal asymptote? Well, go figure. It's a horizontal line, and horizontal lines are written in the form y equals a number that guides the graph of a function but is not part of it. Okay, so horizontal asymptote tells you what happens at the far left and far right of a graph. Tells you how the function will behave at the edges, way to the right and way to the left of the graph. Unlike vertical asymptotes, horizontal asymptotes can be crossed. Okay, they can be crossed. Vertical asymptotes are not in the domain, so therefore they cannot be crossed. Horizontal asymptotes, the x values are in the domain and they can be crossed. Also, unlike vertical asymptotes, a function can have at most one horizontal asymptote. As you'll recall, we can have an unlimited number of vertical asymptotes. Okay, however, when it comes to horizontal asymptotes, we can have at most one. We may have 0, we can have at most 1. So here are some examples. As x goes to positive infinity, the function is approaching the line y equals b here. You can see that there. In this case, this is coming down from above. As x goes to positive infinity, this is approaching the horizontal asymptote y equals b from above. And here's an example of the crossing of a horizontal asymptote. Again, as x is going to positive infinity, the graph comes down from above, crosses over this guiding line, and then it comes back up and begins to be shaped. The graph is then shaped by this horizontal asymptote. All right, let's take a look at how this works and do a couple of examples. All right, horizontal asymptotes guide what happens at the far left and the far right of a graph. That is, when values of x are really, really large, we're going to infinity, or really, really small, we're going to negative infinity. When this is the case, when we're going to infinity or to negative infinity, it's the leading term of each polynomial function that's responsible for what happens. Okay, we'll take a look at what that means. Okay, it's the leading term that drives what the graph is doing. So, when locating horizontal asymptotes, we want to look at matching leading degree terms. Okay, we want to look at the matching ones. If they're not matching, we want to come up with it. Okay? If the numerator and denominator do not have matching leading degree terms, we want to create one. And we'll use a 0 coefficient so that they do have matching leading degree terms, because that will tell us what the horizontal asymptote is, if there is one. Okay, so what does that mean? Fair amount of words, but I think the examples will help. Finding a horizontal asymptote, look at the degree of the numerator and the degree of the denominator. If they are the same, if they are matching, if they're both third degree polynomials, for example, y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator is the equation of the horizontal asymptote. If our degrees are different, we want to create a matching degree term with a 0 coefficient. And then we're going to reapply this. y equals the leading coefficient of the numerator divided by y equals the leading coefficient of the denominator, and we'll either get 0 over a number, which means the horizontal asymptote is y equals 0, the x-axis, or we'll get a number over 0, and we can't divide by 0, so that will tell us there is no horizontal asymptote. Okay, that's a lot. If you look back at this, that's a fair amount of English language to talk math speak. Let's take a look at it with some examples. I think it'll make things clearer relatively quickly. Okay, find the horizontal asymptote, if there is one, of the graph of each rational function. Okay, let's graph it and see. So 9x squared over 3x squared plus 1. Let's first graph it out of curiosity. Y equals, okay, the numerator was 9x squared, and the denominator was 3x squared plus 1. And I got to do some deleting to get these pieces out of there, and I will zoom to 6. And here comes my rational functions graph. Okay, so we can see that this graph it's being shaped by a horizontal line across here. It looks like a bird actually, but there's a horizontal line that is coming across from left to right that is shaping what these ends are doing as they go to positive infinity and negative infinity. Okay, let's take a look at what happens here in this. Okay, we have a 9x squared over 3x squared. Now, when we go to infinity, adding 1 does nothing. In the words of infinity, to add 1 to the back has no meaning, so we could kind of take that away. Okay, now we have an x squared, infinity squared, and infinity squared, and that kind of takes itself out. So we're looking at the leading terms, and they both have the same degree. Okay, they both have the same degree. Okay, let's look up a little bit. If they have the same degree, we can kind of say, oh, I'll take those out, and I'm left with 9 over 3. So if they are the same degree, y equals the leading coefficient of the numerator, which is 9, divided by the leading coefficient of the denominator, which is 3. So y equals 3 is the, and I'll abbreviate, horizontal asymptote. Because the degree is the same, they kind of take each other out with these x's, and we're left with 9/3. Let's go back to our graph, and let's put in y equals, let's put in equation 2 here, 9/3. Whoops, what, 3? They take 3, not 9/3, 3. And we'll see how it shapes the graph. So there's that red line, and you can see how it's shaping it. Okay, it's keeping that asymptote below as it goes to positive infinity and negative infinity. There's your line. Okay, let's take a look at some examples where we don't have matching. Here's our g function. It's a rational function. Okay, now notice. Okay, notice again, we want to look at the degrees, the leading degree. Well, this is a degree 1, and this is a degree 2. Well, that's not going to work for us. So let's change the numerator to have a degree 2 by writing it with a coefficient of 0. So now they're the same. Okay? And so now we're looking here. Okay, so our degrees were not the same, so we created one for the numerator so that they are the same. And so what do I know? Y is equal to, now that they're the same, numerator over denominator. Well, 0 divided by 3 is 0. So y equals 0 is the horizontal asymptote. Okay? Horizontal asymptote. Let's go back here and take a look at this one. I think I got that in there for you. Okay, I'm going to clear this one out. I'm going to clear this one out. And I'm going to put in my fraction bar, and I think I had 9x over 3x squared plus 1. 3x squared plus 1. And I said that the x-axis is the horizontal asymptote. I'll draw in red with a y equals 0. Here comes the graph of this rational function. It's in blue. Okay, and you can see this graph, there you go, there's the horizontal asymptote here. This graph crosses the horizontal asymptote at the origin, but you can see as we go to positive infinity, the red line is shaping the graph, and as we go to negative infinity, the red line is also shaping the graph. So there's an example of the x-axis as a horizontal asymptote, and also of the horizontal asymptote that is crossed by the graph. Okay, so again, the key here, my degrees were different, so I created the same, and then I just took the coefficient over the coefficient. Let's do h of x, same thing. Notice my numerator is a third degree and my denominator is a second degree. So I'm going to write my denominator with a third degree. And I'll just put a 0 in front of it. It's the same thing. It's 0 times x cubed is 0. So now I have, there you go. And now I look at my leading right there. And I look at the coefficients. And this gives me y equals 9 over 0. Well, guess what? You can't divide by 0. So this tells me no horizontal asymptote. Impossible. Okay? So the key to these horizontal asymptotes is to match up degrees, building one with a 0 coefficient as necessary. And then you just need to look at the coefficients of the leading degrees, and you will come up with the horizontal asymptote if it exists.